evening and welcome. Welcome to InterSystems Developer Community Meetup. This is our first meetup that we've done in Cambridge. So you guys are paving ground for everyone that will follow you. My name is Jim Breen. I'm the Director of InterSystems Education. And on behalf of InterSystems, I want to thank you and welcome you all here tonight. And I'd also like to thank the folks here at Cambridge Innovation Center for their hospitality and having us here tonight. So I know you don't want to hear a lot from me tonight. What you really want to hear about is our products, and we really would like you to hear from each other. We really want you to take the opportunity to get to know one another and really get to know our technology, what it can do and what it can do for you. We also have plenty of food, we have plenty of drink, so we hope you will stay until you finish it all. And during the meetup, a meetup is supposed to be somewhat informal, so like during a presentation, feel free to get up if you want to get something to eat or something to drink. Or if there's someone you want to talk to and you feel like you might be running out of time, feel free to go over into the corners. That's what this is for you to really meet and talk and discuss. We're going to have 3 presentations, and I'm going to introduce the person who's going to be hosting the rest of the evening. For those of you who don't know InterSystems, we're actually maybe a block away. If you look behind that white curtain, like the man behind the curtain in Wizard of Oz, that's where InterSystems is. So maybe later on you can peek behind that white curtain and get a look at our company. So we're on 1 Memorial Drive here in Cambridge, and we have a lot of great technology that we hope you'll get to see tonight and learn about. We have a number of InterSystems folks here as well, so they're here to answer questions that you may have, and also get to know them and what they do at our company and what our company does. So without any further ado, I want to turn this over to Evgeny Shirov, who is the director of our outreach and our marketing and our developer community. So, Evgeny?
Thank you, Jim. Hello, everyone. It's our meetup, and actually, Jim presented it very well. So I just had a few words that why you are here today. So we want to be successful with InterSystems, and here today you can find InterSystems employees, developers, and support engineers, even product managers. And here are our loved customers who are very successful with InterSystems for decades. And here are our maybe future customers and future partners. Today evening is for networking, as I said, and we would share sessions about InterSystems data platform. And recently we launched InterSystems IRIS, our new data platform solution, and there will be sessions about that. And actually, so I would love to invite a developer of our new feature of InterSystems IRIS. It is Sharding developer Jeff Miller. He will be a first presenter. And as I said, you have a kind of unique situation just then after the session to catch Jeff and ask all the questions how you can be successful with our InterSystems data platform Sharding, and that's it. So welcome, and please enjoy and be successful with InterSystems. And today there will be sessions from InterSystems employees, and actually you're very welcome. Stay tuned on developer community. Developer community is our site, community.intersystems.com. And you're very welcome to, on the next meetups, to share your success stories, to share your services you build and you have successes with InterSystems. Okay.
Yeah, I know. I've got some message.
Thanks very much, Evgeny. Hello, everybody. I'm Jeff Miller. I'm a lead developer on the sharding project, which is a core component of the new InterSystems IRIS data platform. In fact, it's pretty much the earliest piece we started developing before we were sure quite what this product was going to evolve into. Early on, I actually suggested calling the product Chardonnay. For some reason, that didn't catch on. I guess the feature is there anyway. So I'm going to be talking about putting sharding in the context of a number of scalability techniques and capabilities, some of which have been with InterSystems products from day one, some of which have evolved over the years, techniques which can be used together to solve scalability problems. There we go. So scaling has become more and more of a buzzword these days. It's kind of mom and apple pie to talk about how companies are getting larger, using more and more data, spreading out on the internet, using the cloud, and this creates greater and greater needs for scaling over large amounts of data, large number of users, increasing bandwidth, and so on and so on. InterSystems IRIS lets you scale in two directions: up, vertical scaling, out, horizontal scaling. Lets you scale users and data, and lets you mix a variety of techniques to suit the needs of your particular application, your particular environment. First, we'll talk about vertical scalability, which has been around the longest in the industry, and which InterSystems, as I said, has excelled at all along. Vertical scaling is letting you handle larger and larger workloads with greater and greater throughput by increasing the size and power of an individual server. So you can add memory, CPU, disk, networking capability, a number of components to increase the power of a server, either add these over time to beef up its power, or plan it in advance and pick this size and scale of the server that you're going to need for your requirements. So it's kind of architecturally simple to think of, okay, my problem was always on one machine, it's got to be bigger now, I'll have one bigger machine. Although there are still software complexities to be solved in taking advantage of multiple cores and other aspects of scalability on single larger machines. If you plan carefully, you can get fine-grained balancing in terms of matching the hardware exactly to your needs. But the downside of that is you have to plan carefully up front, or you end up either being stuck with an undersized machine that isn't meeting your needs, and because it's one machine and you hit its limits and can't add anything more to it, you're stuck having to start over with a bigger machine. Or you overestimate and you're stuck with power that you aren't really taking advantage of, sinking investment that isn't getting you back anything. Also, in general, there's the nonlinear price-performance ratio. So you pay more money for each additional amount of throughput, for each additional amount that you can make your data load larger. Still, this has been around for a long time. We do very well at it. And one of our newer techniques, not brand new, it's been around about a year or so, one or two releases in the SQL arena, is parallel SQL query execution, where we are able to transparently, on the fly, figure out a way to partition a set of tables that are being queried across multiple cores, run a separate job per core, and thereby be able to execute the pieces of the query in parallel, then execute a combining query that aggregates the final results. Today, you hint to the optimizer that you want to use this technique with the percent parallel directive. We're working on making this transparent. In fact, in some aspects, it's already become transparent since this slide set was put together just a few weeks ago. Now, in horizontal scalability, scaling out, rather than talking about making one machine bigger and bigger, more and more powerful, you add more machines in order to add more capability, And if you do it right, you're able to approach linear scaling of your throughput and of the size of the workload you can handle as you add a given number of more machines. This has an advantage of nearly linear price performance because, as I say, if it's done well, you get nearly linear scaling, and each individual machine doesn't cost you any more than the machine that you paid for just before. And it enables you to have at least the option of using commodity hardware or the cloud or virtual machines. Basically, whatever processing power you can start with as a unit, you can multiply that by the number of times you replicate it, although there's nothing to preclude you using multiple powerful machines. The software complexity side of this is somewhat more of a challenge. Putting that as one bullet kind of understates the challenge. In fact, most of my life, the last few years, has revolved around solving that software complexity. So that's what we'll be looking at in more detail. Also, of course, as you spread your application processing and your data processing over multiple machines, they're connected by a network, and as everything else becomes as well optimized as you can make it, the network now introduces a new area to become your bottleneck. Not to say that this is not a reason to go in this direction, just there's always trade-offs to consider. So first let's look at horizontally scaling users. Let's say we've got a large set of users who all want to access data on a particular server, a big purple box, let's call it purple, not blue. And because big blue, we don't want to go across that too much. Right, so they're all running applications which the applications themselves might be able to run independently, except they're all accessing data on the same server. So a way of horizontally scaling that would be to have their application run on multiple machines, a smaller subset of users per machine, but have them all have a way of accessing the data on one server. InterSystems has a, by now, quite mature and robust technology to provide this solution called Enterprise Cache Protocol, or ECP. Now, ECP is a very powerful generalized cache server, distributed cache server, which can be used in quite a variety of ways, but one of the most standard ways of using it is to set up application servers where each application server sees all of the data that's available on your data server, but accesses it at a low-level shared cache level. So all of the application logic, including your SQL processing and so on, is happening on the app server, and it's just at the level of serving up cache pages when either your application hasn't seen that page yet, or the page has become invalidated because it was updated somewhere else and you need a fresh copy. Then ECP transparently takes care of keeping those pages in sync and up to date. But once your application has the cache pages it needs locally, it can operate largely in memory. And by spreading your users across more app servers, each with its own cache, you're getting horizontal scaling of cache, not by making the cache that each user sees bigger, but by having less contention from other users for that same size of cache, so that the odds of a given page that you need being in memory when you need it are much higher, so your application runs faster, you get greater overall throughput for an increasing size of users and increasing number of applications. Now let's look at horizontally scaling data. This is a newer area for us. In fact, this can be brand new with InterSystems IRIS Data Platform. Here, let's suppose we have large amounts of, we're representing the separate chunks of data down below, and instead of looking at them all being on the same data server, let's imagine that we could spread them across multiple data servers, but somehow still have a way of accessing them so that transparently it looks like the same set of data that you can do the same things on and operate your SQL queries, your SQL applications, without having to think about the fact that your data is partitioned. This is where we introduce the technique SQL sharding. We didn't invent the word sharding, but we have a rather unique approach to it, which I think after I've explained it, you'll see has a lot of potential to outcompete other implementations of sharding, in part because we're able to leverage ECP and leverage other aspects of InterSystems data platform. So SQL sharding lets you partition your tables across multiple InterSystems IRIS instances, which can be, or typically would be, on separate machines. So it's taking what you can do with parallel SQL that we looked at earlier, kind of an order of magnitude step further, because you're not just parallelizing the processing in multiple cores, you're spreading the data out on separate machines. You're moving the processing to the data on each of those machines, so that for each subset of data, you have a whole cache of a whole machine for that smaller subset of data. And then a magic until we get to the next few slides at least, pulling the results together and transparently making it look like you were accessing one large or a set of single large tables. Here we're horizontally scaling cache in a subtly different way. Again, as with app servers, each of these, what we're going to call shard servers, each has its own complete cache. But rather than just saying that a given user is just seeing one of those caches but with less contention, now they're seeing the additive, the sum of the cache sizes of all those caches. So if you imagine that on each server you had the maximum size that you could scale a cache to on one machine, well, now you can just multiply that by as many machines as you configure together, so that a much larger data set has the potential of all fitting in memory, or at least large parts of it fitting in memory. Excuse me. Try throw it as a sign that I'm talking too much, so I'll try to go a little faster. Before we get into the details of this, I will kind of presage what I'll be saying by saying that you can mix and match these techniques. You can have horizontal scaling of users together with horizontal scaling of data, scaling each of them separately, deciding how many machines you need to handle your user load versus how many you need to handle your data load. And although the slide doesn't show it, you can also mix and match vertical and horizontal scaling. That is, for some applications, it might make sense to use the cloud or use commodity hardware. But for the highest end, most demanding applications, you might want each of the servers, at least your data servers, to be the most powerful machine you can configure to get the maximum vertical scale out of it, but then multiply that by the power of multiple servers. And in fact, you can, for example, combine the approaches of SQL sharding and parallel SQL, where on each shard server it uses parallel SQL at the same time that it's using sharding across the entire query. And this is not just theoretical at this point. We've got pilot applications going with some large customers where we've seen multiplicative throughput improvement and query performance improvement by having both parallel query and sharding going on at the same time. So now to look at more detail of how SQL sharding works. In the simplest version of a sharding architecture, there are two basic roles that instances play. You have one shard master and one or more shard servers. So the shard master looks to the outside what your single monolithic data server would look like, and transparently, that's what you see. That's where your tables are defined, is where your metadata lives, and it's kind of the entry point to getting at sharded data. And you can still in this environment have non-sharded data, and it resides on the shard master just as it would reside on an ordinary data server. But you can also have sharded tables, and their data does not actually reside on the shard master. It resides partitioned across the shard servers. So the shard servers provide scalable storage for the sharded tables, and the non-sharded tables are still visible from the shards thanks to ECP. which means that the components of sharded queries that are running locally on the shard, if they need to see a non-sharded table, they don't have to either replicate that non-sharded table on each of the shards as many sharding products do, nor do they have to send a message back to the shard master saying, I need these rows of this table. They can simply see it on the master as if the shard was an app server. So this the same technique that's been around for years, works very well, saved us a lot of testing because a lot of the moving parts of this have been well tested for years, and this is just a matter of taking those pinky toys and putting them together into a new robot model that does some cool new things. So a big part of the secret of sharding is we're moving the processing to the data. And that's how, one of the kind of mind switches people need, if they're familiar with doing various kinds of distributed applications on InterSystems platforms in the past, just using ECP, they picture that your applications are running in one place. It needs some data here, some data there, some data there. It gets it all over ECP, just at the cache server level, but your processing is still running on your app server or your master data server. With sharding, your application starts by sending the query to the shard master just as it would send it to be executed on a regular app server. But the shard master, what I call, and I don't know how standard this is, but it's a term I've used in a number of incarnations over the years, decomposes the query. It takes the original query and it decomposes it into a shard local piece that it sends to each of the shards that can come up with the intermediate results of the data from that shard that's going to satisfy that query. And the shard servers each send back that intermediate result to the shard master, where it then executes the other piece of the query, the combining query. Actually, it's doing all this in parallel. The combining query pulls together and aggregates the results from each shard to form the final result of the query. In trivial cases, this just means take a row from here, a row from here, and send it back. In more complicated cases, it has to transform your aggregate functions in order to get the raw materials it needs. For as a simple example, if it wants to compute an average, then it needs to get the sum and the count from each shard so that it can produce the final average across the whole table. And finally, the shard master sends that final result back to the application. Now, there are a couple additional roles in a more complicated configurations that you can do with sharding. First of all, what we call shard master application servers. As I said several slides back, you can combine scaling users with scaling data. So shard master application servers are simply your regular ECP application servers, but pointed at a shard master that has shards behind it. Excuse me. The reason those are different is while they access the non-sharded data on the shard master data server, just as an ordinary application server would access non-sharded or any data on a data server, when they access sharded data, they behave as a shard master. That whole process I described, decomposing the query, sending the shard local queries to the shards, aggregating the results and giving them back to the user, happens on the application master. That means the cache that's needed for aggregating those intermediate results is partitioned or is replicated across all of the application masters so that the shard master data server does not become a bottleneck. You can scale multiple users running sharded queries, have the shard local components scaling on this data shard level at the same time that the combining and application portions are scaling at the application level.
Jeff?
Yes.
Yeah, quick question. Does that create some load challenges for the shard, where all this shard data is? There's all these different shard master app servers that are also accessing application?
Well, it can, and that's a very good lead into the next slide.
You're welcome.
Okay.
Just a second. Michelle, thanks. Actually, folks, it's a meetup. If you have any question that you want to ask for presenter, please don't keep it with yourself. Please. Thank you, Jeff.
So, yeah, please do interrupt, because I know how it is if you have to save all the questions to the end, you lose the context and forget what you were going to say. But anyway, so another specialized role is what we call query shards. And what query shards really are is application servers in the ECP sense of the data shards. We don't call them query application servers, although we did originally, because it's a little confusing since the user's application isn't running on them, but the shard local query runs on them, but sees the actual data through ECP. That means you can configure multiple query shards per data shard to spread out the bandwidth at that end to better handle the increase in bandwidth that you could get by having application master application servers on the front end. So you can tune it with experimenting, seeing where your bottlenecks are, see which you need more of to get the bandwidth you need. So with query shards, one advantage of query, well, there are several advantages to query shards, and the comfy chair and all that, but the one advantage is that they're more elastic than data shards, because with data shards, you've actually partitioned, okay, I put this data here, this data here, this data here. If you want to add data shards, repartitioning the data is an expensive operation. This is a problem for any sharded product, and one which we don't handle yet transparently. There are ways that you can handle it, but with query shards, since they're just pointing to data that's already there, you can add and remove them anytime you want to without having to interrupt your applications running at all. Just the next query that comes in will grab the next available query shard using automatic load balancing for each data shard. It doesn't make one individual query any faster, but it means that your aggregate bandwidth that you can handle with multiple users running multiple sharded queries increases with the number of query shards. But the other big advantage is, since when you configure query shards, select queries that are retrieving data, automatically run on the query shards, whereas other DML operations, inserts, updates, deletes, DDL operations, those run directly onto data shards. So if you have an application load where you need to do a lot of high volume data ingestion, data loading, at the same time that you want to run a lot of expensive analytic queries, this is the perfect solution. Your ingestion load is directed through via the master data server directly to the data shards, while your analytic load is handled by the query shards. So two separate sets of scalable cache. One set of scalable cache handling your ingestion at the same time that a different set of scalable cache is handling your queries. Of course, there are special cases in which you still have to consider possible cache interference. If you're querying the same portion of the data that's being updated, then cache pages are going to be invalidated and have to be updated in the query shard cache and so on. But in general, this is a very powerful technique for allowing multiple workloads to run in parallel, and then each of those workloads scale itself in parallel. Now, joining tables is a difficult thing in any distributed architecture, because if each table is scattered across many machines, and in the worst case, you're considering a cross product where each row on each machine needs to join to each row on each other machine of the other table. Well, this can be abysmally expensive if it's done wrong, or just plain impossible in some architectures. What we provide is a three-part solution For your most needed, most often used joins, we give a blindingly fast way of making them scale just as linearly as non-join queries, while we can also handle any join between sharded tables reasonably well. And then we also give the option of joining sharded tables to non-sharded tables totally transparently without requiring replicating the table. So among these three techniques, as you plan your schema for your application needs, you can come up, just as you might have to plan your indexes or plan other aspects of your schema design to suit your application. You can plan how to lay out your tables to have the join techniques that you need. The co-sharded technique, which is our fastest approach, lets you define a shard key on each table, which can be one more field which we hash to decide which shard each row goes to. And if two tables have the same shard key, that means two rows with the same shard key value are guaranteed to be in the same shard. That means that any join that has an equals comparison of those shard keys can be executed entirely locally on each shard without any crosstalk between the shards at all. So it scales totally linearly. In the more general case, we leverage ECP to say, okay, we're still running each shard local query on one particular shard, but if it needs to see data on another shard, it doesn't have to send a message to that shard to run another query and come back with partial results. It can simply access those rows on the other shard via extended references over ECP. We have an algorithm which we call the shard tuple algorithm. A shard tuple is basically one permutation of a row of each table from a particular shard, and we assign those permutations to different shards in a way that maximizes locality of reference while minimizing cache thrashing by making sure that as much as possible we're going through those permutations in the order that will tend to reuse cache pages that we already have locally. And then finally, as I said, you can have non-sharded tables, which in many products would be the tables that you would have to replicate, and then every update would have to go to all shards, et cetera, et cetera. Here, a non-sharded table is simply a traditional table that we didn't do anything special with, so it's living in one place, but it can be seen by anywhere on your sharded cluster. And so, as you're defining your schema, if the tables are not big enough to particularly need sharding on their own, but they're going to be, whether or not there can be used with other sharded tables, you can just go ahead and not shard them, but then if you need to join them with sharded tables, it just works. This is my final slide, and hopefully I haven't run over too much. Just to say that not only do all our scalability techniques work together, but of course sharding leverages and works well with a lot of other features, many of which have been around a long time in our InterSystems products. And particularly worth mentioning mirroring, which provides us a very robust high availability solution. So you have the option when you configure a sharded cluster that any of the data storing components, the shard master data server or the shard data servers, can be mirrored, and that means that if a machine fails, it will automatically fail over, have totally up-to-date data on the backup failover member. And if you're running a query and one of the shards or more than one of the shards fails over, the query will transparently be completed. Internally, it might have to restart it and retry it a number of times until it gets a complete set of running shards that lets it run from start to finish. But from your application's perspective, it just means it took a little longer while things were failing over, but you didn't have to build the logic into your application to figure out how to restart your queries in the face of machines failing. Another important new component of InterSystems IRIS data platform, which hopefully will be talked about in another of these meetups, is the InterSystems connector for Apache Spark, or just the Spark connector as we call it, which leverages our sharded topology to let you bring to bear the parallel application execution and analytic power of Spark, which is originally part of the Hadoop ecosystem, but has been generalized so that it can be pointed at other data sources. Well, we've not just enabled you to point it at InterSystems IRIS data, but really add power to it so that it works powerfully together with sharding to figure out where the data is, move its worker jobs close to the data, access sharded tables, create tables. And I'm unfortunately not an expert on that myself yet, but it's well worth looking into. Finally, JDBC, which is sort of the lingua franca of accessing SQL data, will transparently, at its own level, parallelize those operations that make sense to do so, and particularly data ingestion, that is batch inserts. So if you're inserting a lot of data into a sharded table through JDBC, rather than the shard master becoming a bottleneck where each row has to go there and be allocated out to the shards, the shard master brokers a connection transparently. It tells JDBC, here's the addresses of all the shards you need to talk to. Here's how to transform your insert set statement to talk to those shards. And JDBC automatically creates threads that talk directly to each shard, does the inserts in parallel. You don't even have to know what's going on. You just write an ordinary JDBC insert application that does it for you. Well, I could go on, but I've run out of slides, so any questions?
Thank you, Jeff. So questions to Jeff.
Yeah, do you have examples of customers who are maybe trying this out or
Well, I
trying an
can't name.
Yeah, but how would describe an application
Yeah.
as really
We're working with a large hospital in the greater New York area. The only specific thing that I can tell you about it is that I was born there, so we're kind of returning the favor now. And
What charts are paused?
the interesting thing, that's actually a health share application.
How does that
And it's kind of stretching our sharding capabilities because in first release we're saying sharding just supports SQL, and second release we're going to support it at the object level. But since health share heavily leverages objects, we've actually discovered, or some of our smart SEs have discovered that there are backdoor ways that you can already take advantage of object features through sharding, which we will be productizing more in the next release. That's the application one, as I said. We found a lot of their queries that are benefiting from being sharded and being run in parallel on each shard at the same time, so that in some cases the total speed up is almost mind-blowing. It's like several times a greater factor than the number of shards, so that they're seeing better than linear speed up, and then comparing to the competitors that they're running benchmarks against, more than that still, because in some of these cases, just straight ahead health share with our existing technology was already faster. We've also got pilots going with a couple of big investment banks, one of which has been a customer of ours all along. Harry Tong, our lead New York SE, has been working with them to adapt their existing application where they had done partitioning homegrown using ECP, but he's used our query shard technology to actually be able to point InterSystems IRIS query shards over ECP at cache data shards. Well, they weren't even shards before this, and it actually all works. So it can, where before they were limited to a kind of union all, very simple set of queries that they were able to define across their ECP partitions. Now they can take advantage of transparent SQL, being able to execute any SQL query across that same data that they already had. we're still in an inception phase. There's a large Japanese company that's looking at doing instrumentation of hospital rooms so that all the data that nurses go and collect now will be going directly into a large database. So high volume real-time data capture and then analytics run on that, and you need to do aging out data over time. When we did these sort of talks at Global Summit, we pushed SEs up to talk about use cases. So I usually rely on them for the details, but hopefully that gives a little bit of a flavor of that. Yes.
Who are your major competitors, and what is the unique value proposition when you compare to the marketplace?
I'd say on the one hand, we're obviously competing with large SQL vendors such as Oracle.
Yeah.
On the other hand, a lot of sharding-like technology has been more prevalent among NoSQL vendors or key value products, and a lot of the data lake and those sorts of applications have been more on platforms like Hadoop, which, although you can layer relational technology over them, are really much more distributed file servers than anything else. So I think our unique value proposition is that we're bringing these scaling capabilities together in an already very mature, ready for business applications data platform that isn't just doing scaling and fast data access. It's a soup to nuts product that does all the things you expect the data platform to do, except now we're also able to scale this way. So I don't think there's one technique here where other than the ECP, I wouldn't say there's one technique here that's unique to us. It's the combination of them, the way they can all work together, and the way that they leverage 37, how many years now of evolution that we have now of InterSystem products that just keep getting more and more powerful and more mature because of our philosophy of continuing to support our customers across all of our evolutionary breaks. And this one is no exception. Everything that's good in previous InterSystems products is still there in InterSystems IRIS, but we're adding flexible, state-of-the-art scalability. And I'm not a salesman, so I'm sure our salesmen could do a better job of selling that. But
You do very good.
All your next questions you can ask directly to Jeff. He's here. Please catch him. And now the next topic. Next presenter is Michelle, who is one of developers of InterSystems IDE Atelier. Michelle, we are preparing a laptop. And as I said, you are very welcome to ask questions during sessions. Please ask questions, and also actually we do live streaming now, so be prepared. You're being filmed. Your internet, and we have some people online, and presenters be ready to questions from the internet. May I ask you who is already using Atelier? Yeah, some hands. Sorry.
Let's see.
Good replay.
What is it on that?
So,
I'd rather not.
Michelle, we can start. Yes. So this is the mic. Yeah, you do.
All right, yes. Good, awesome, thank you. We're ready.
Let's go.
Hello, everyone. My name is Michelle. So yes, I'm the tech lead for Atelier. I've been working on it for a few years now. And I like to think of it as a power boost to any developer. So if you have any gamers here, you know what a power boost is. Basically, it makes you more powerful. Yeah. So just really quickly, we're going to briefly go over Atelier. I'm going to show you a typical workflow for any developer. We're going to squash that bug. And then we're going to, you can laugh, guys. Okay. And then we're going to look forward. So what's the future of Atelier? So yeah, so question number one, how many of you are familiar with Atelier? Maybe you're using it right now. Anyone? Come on, be proud, be proud. Okay, so which version have you used? Fill it out. Do you know 1.0, 1.1? Newest? Newest? Everyone's newest? All right, cool. Why did you care to use Atelier? Can someone just scream out some examples of things that you liked about it?
Cross-platform.
Cross-platform.
Source code integration.
I didn't hear it.
Source code integration.
Source code, yeah. So version control. All right, so these are some things. So we've got cross-platform. I'll talk more about all these. Source control. There's a bunch of plugins you can leverage, so a bunch of extra functionality, and for training, for hiring new people. What are some IDEs or text editors folks here are familiar with? Is anyone familiar with Studio? Anyone? Yeah, everyone. If you're not if you're a developer, you didn't raise your hand. I don't know why you're here. What about like these simple text editors? Anyone? Yeah. Or favorites? Any of these favorites for anyone? Anyone? Yeah. Okay. Eclipse. Anyone an Eclipse user? Yeah. All right. A few. All right. So. Atelier is a plugin for Eclipse, okay? And the major things you need to know in transitioning from Studio, or if you're starting with Atelier, is that we've moved the source of truth to the client, and that now the server is a deployment target. It's not where you write your code anymore. So I've got these little illustrations to help out. So previously, you'd compile, that's what this little gears mean. You would compile and execute all your code on your database, and that's still true. You still test all your code on the database, on the server. But whereas before you would write your code to the database, now you write your code to the client. So this is a little bit more what you would expect if you've developed with any other technologies. So some of the benefits from people who have been using Atelier are pioneers. You guys mentioned it already, it's cross-platform. So no more Windows VMs for you Mac users. Source control options, so whatever your team is using, it's probably already supported for Eclipse. And it's going to be more reliable because the teams that develop that source control are also managing these plugins. So your team doesn't have to bother with it anymore. I say it's infinitely customizable, but it's effectively infinitely customizable. Whatever you want, you can probably find a plugin that does it, or a cool hack to make your life easier. And that's where the Eclipse Marketplace comes into play. And then finally, some really cool benefits are, it's really easy to get training, right? Eclipse has been around for a long time, so it's a simple Google search, and you're gonna find your answer almost definitely, immediately in the first page. And it facilitates hiring. So new grads, anyone who's about my age, probably learned how to code on Eclipse or something similar to it. So it's really easy for them to get started with Atelier, and any other software experts, right, who are also familiar with these newer IDEs will be able to hit the ground running. All right, so distribution. Distribution is very different than from what Studio was, if you use that. So it's not tied to the platform release schedule, and it's not going to be included in the platform release. So if you're used to the queue on Windows, you would click that, and you would see a Studio option, right? You click that, and that's how you would open up the IDE. That's no longer the case for Atelier. So for starters, going forward, we have a goal to release every quarter. So the first quarter of 2018, you're going to see a new release of Atelier, and we'll have field tests every month. So we've got another field test coming up any minute now. Hopefully it'll be this week, so look out for it. And you can get that from the update site. So this is how you install. You install from an update site. This is a normal thing for Eclipse. And this is the URL for that. And it'll never change. It'll always be the same. If you want to see the latest work we've got that we're ready to show you, you get it from that URL. And you can go to intersystems.com/atelier for all the details. If you're like, what does that mean, an update site? Go there and you'll find those instructions. All right? Any questions? No? It's clear enough? I'll let you take your photo. There you go. Okay. All right, so now we're going to go to a demo. And this is just a typical thing. Everyone's done this a million times. You open up your workspace, right? You look at the stuff you want to work with. You update your source control. You debug your app. You make your change. You test it. You launch it. Yep, it works. And then you submit your change, right? And then we're also going to do a little extra demo of a SQL query because it shows how we can leverage plugins. Sorry if I'm breathing in the microphone too loud. Okay, so anyway, so this is Eclipse. This is Eclipse with a plugin in it. I'll show you real quick about Eclipse. Here's Atelier. Cool, it tells us about the version I put in. So I got all these projects. These represent projects from the samples namespace because it was the easiest thing for me to get to. All right, so what's the first thing you do? You got a bug, right? So we have, I'm gonna set it up for you. We have an intern who is supposed to set up authentication for our app. It's pretty simple, straightforward, everyone does it a million times, but they didn't do it right. All right, so we've got this key. I set this up already. Key 2339. It's very realistic. So I created a working set. So now all I'm looking at is the project that is related to that key, to that issue. And if we open this up, I'll just walk you through it real quick. We've got a connection, so I called it released 2017-2. It's mapped to the samples namespace. Got all these CSV files, and I've got a few class files also. Okay, and I already created a launch configuration. This is how we run the application. So I'm just going to click that, and it'll run it right here. I'm sorry, Andreas, I'm going to use system. Don't be angry at me. All right, so here's our app. We're going to join username. How about DC, for developer community? Developer community. All right, cool. So we've created our user. We can log in. Cool, that worked right. So what's the problem? Let's try again. That was expected. Okay, so let's put in a wrong password, okay? Still let us in, no. Right. We're gonna do this one more time, and I'm gonna do it with a bad user, the one that doesn't exist. Fred. Oh no, we have an error. Okay, so you guys have seen this before. This is an easy one to debug, right? But it makes the point, right? Okay, so user doesn't exist, right? If we read this, we can tell. We reference something that doesn't exist yet. And we can see that it exists in this class, right? So we want to open up that class, and we want to find the authenticate method, okay? So here's the class. Just open that up. Oh, so this is great because it's not checked out. So I forgot to update everything. That's okay. So we're going to go to team, checkout. Yeah, sure, get the latest. All right, so it's checked everything out. The icons changed. I selected the project, so it checked everything out. So I don't have to worry about this again. So user, go to my outline, go to authenticate, create my little breakpoint. I'm going to do this again, but now I'm going to choose debug. Let's close that debug session. One. So now we're going to put in our bad user again. And it broke, right? So we're debugging CSP right now, right? This works. You guys can celebrate. Yeah. Great. So first thing, I'm going to show you some variables. Username is Fred over here. I've got a password of T. I can step in. And it takes me to find user. Cool. I can step out. It takes me there. I can step into my do. Right, and I can be looking at my my variables. I can put in an ID if I wanted to here, and it would run with that. I'm not going to do that because that's not the demo I want to do. All right, so here we see user is empty. That's what we expected. We know why, because the ID is empty. So I'm going to go ahead and stack this. Oh, I wanted to show you one other thing. Let me do this really quick. One other cool thing, I wanted to show you the debug stack. This is useful for more complicated examples. So, okay, so here I am. This is the debug stack. If I double click on here, I was expecting something else. That's okay. Anyway, if you click in here, as long as it's well, here a little explanation. Int files, right? It depends on whether your compile options, whether it's kept around or not. So if it's not kept around, then you'll see this. But if it is, then it'll open up for you. All right. So that wasn't worth it. Sorry about that, guys. Anyway, so you can debug. You can step through stuff. You can step in and out. You can set breakpoints. I can show you more about that, but I'm not going to. Instead, we're going to just fix this right away. All right, control save that. We compiled it when I saved it. If we want it, we can run it again, and we'll see that it'll work. Oh no. There we go. One last time. Go. Yay, did the right thing. All right, so we have to stop our thread so that it doesn't keep running on the server. All right, so now we debugged it, we made our fix, and then in the Atelier Explorer, or actually if we go to our perspective, so perspectives in Eclipse, if you're not familiar, are basically just layouts for your different views, for your editors, for the different tools that you want to be accessing. So this is my perforce one. And if I go to my change list, there's a bunch of stuff that got changed. I'm going to say revert unchanged. Lots of stuff. So I checked everything out. This is my only change. Do a quick check that it changed what I thought it did. You see here, there's just one change. I can click it. It shows me what it was. That's what I extract. So now I'm going to submit it. Submit. Fixed it. Ooh. Okay. And it's done. Now my teammates can get this fixed and we're completed. Woohoo! Yay! So yeah, so I showed you a lot of stuff there, right? So the way we connect to servers, you can connect to more than one server in the same space. You don't have to be opening up a bunch of windows to access all different namespaces or servers, right? You just, where are we going? Change connection. I can change this and connect it to anything I want to, right? No matter how many instances I have, no matter how many namespaces. It's all in one place. Debugging. We have regular debugging that works, but we also debug CSP, right? So it's all really great. And we have source control. All right, so if you have other, oh wait, there's more. SQL. So we just got a cool talk about sharding. We can also do SQL queries from Eclipse. So there's this specific plugin that I have. It's called the SQL Explorer. Let me make sure I'm connected. I'll connect. Okay. So now I see my data structure. I see all of my tables in here. I'll go to samples, sample, tables, person, right? I can see all this stuff in here. And I put some queries together that are pretty easy. So open editor, right? You can edit this however you like. I'm not going to teach you guys SQL. You guys already know it. You run it, and there it is, right? You see the results right in front of you, right? All in one place. That's pretty cool. I didn't have to go to the management portal. I didn't have to click around. It knows it. It's all right here. All right. So we like that? Is that cool? Are we happy with that? Okay. Fine. Do that, guys. All right. Cool. So looking forward, Atelier does a lot. The plugins from the marketplace, they do a lot, but there's still a lot of stuff that we can improve, some features that we can add. So here's a list of some of the most requested things. One or two of these things might grab your attention more than others. Go-to tag, that's going to be the next big new feature that we put in. Syntax checking coverage, especially for embedded languages, is going to be improved, and an improved graphical editor. So if you've tried to get the graphical editor for BPL or DTL and you had trouble finding it, it's there, but what's going to be coming is we're going to make it easier for you to find it, because you should not be confused by that. And a bunch of other things that I've listed here and that I haven't. So again, just to remind you, go get the beta. Yeah, go get the field test from this this URL. Let us know what you think. You can also get notes from us, news from us from the developer community. If you all are familiar with this, you can subscribe, clicking email or RSS down there by going to the Atelier group, and you can get all that info. Do you all take your pictures? You good? Okay. But more than anything, we want to hear from you. Really, this product doesn't really mean anything if developers aren't using it, right? That's the point. That's why we're making it, so you guys can make great applications that matter, right? So join a focus group, right? Help us actually shape Atelier. Help us figure out what is most important for us to focus on, right? You can email Joyce. Joyce went away to the crowd. Yes, his friendly face over here in the corner. If you have any bug or enhancement requests, you can contact the WRC, right? They're excellent. They're our crown jewel, right? We all love WRC and support all those experts there. We've got a whole set of Atelier experts that are just waiting. We can't wait till you ask them a question. So please contact them. And then if you have any, tips or any questions, post those to the developer community, right? We're watching. Our team is watching this, and as soon as something's up, we notice it immediately and we do something about it. So yeah. So if there's a question like, oh hey, I'm used to being able to do this with my favorite IDE, but I can't find it in Atelier. How do I do that? We'll answer the question right there. Or maybe you're having fun going through the Eclipse marketplace and you found a plugin that's really, really useful. Post about that. We'd really appreciate that. Or maybe there's something that tripped you up that you think other folks might be getting tripped up by as well. You can post about that. Or anything else you want. Anything else. So yeah. So go to the community, learn more. That's what I got. All right. Thank you, everyone. Are there any questions?
Any questions?
No? All right.
So as you see, development with Atelier is very exciting. So please direct the questions to Michelle and here and Joyce, of course, and to developer community tomorrow. So now we have a networking break. So there is food, beverages nearby, and so very welcome. About half an hour.
Yeah.
I've already wanted to go in.
try to cover some of the high availability options that are available to our customers. Some of this, some of you already heard about. Some of them are new or relatively new. And hopefully I'll be able to answer all your questions. And at the end, I'll talk more about how this works together with sharding, as Jeff described earlier. So first and foremost, talking about the business continuity concept. At the end of the day, it boils down to having our IT systems up and running 24/7, 365 days. Our tolerance for downtime is being dwindled by the minute. Between the cell phones and the laptops and Wi-Fi everywhere, the average person acceptance of any downtime is going away. But in order to do that, there are a couple of layers of things that need to be addressed. The first and foremost is from our perspective at a database level. In order to do that, we need to maintain data integrity. Once we accept a transaction and it's committed, there's a guarantee there that it's bulletproof. We keep the data safe. There's no way to change that data or anything like that. And so that's the first layer. And this is all implemented inside the code of our kernel, etc. And I'm not going to talk about that. The next level up is logical error. So what happens when a user comes in and say delete star, or just deletes a single record, or a simple user mistake? Ransomware, logical error. At that point, if somebody tells the database to encrypt itself, it goes ahead, it encrypts itself. And how do I roll back from that, assuming it's an error? And the simple answer to that is backup and recovery. There are multiple ways to do that. We're not going to talk about them here. The third level is providing high availability. So we have a database, it's up and running, we assume the user didn't do any errors, and we want to keep it up and running. In order to do that, we need to make sure that the infrastructure that is providing that database is always up and running. And how do we do that? The CPU can fail, the disk drive can fail, and anything in between, power, etc. So that's the concept of business continuity. When we talk about the data server resiliency, now it's not only the database, it's everything that serves the database, including the data, power, etc., processing power. And you want to minimize the downtime. And you want to set it up in a way that if something happened to a single component, it immediately fails over to a different system. In other words, you want to build redundancy into each and every component in that supply chain that provides the database with whatever it is that it's doing. Now, we used to be able to do that in hardware. If any of you is familiar with the IBM mainframes, and there were systems where you can hot swap CPUs, just as an example. Most commodity systems do not support those capabilities, and you compensate for that using other means. But the three major things that we're supporting are, first and foremost, database mirroring. That's implemented at the database level, and some people call it journal shipping or log shipping. The idea is that every change that is being written to the globals, being written to the database, gets replicated somewhere else. It gets sent to a separate system, or it gets applied to the database. And assuming you keep both in sync, so every I/O on system A is immediately transferred to system B, you're good. There's complete. It's a complete copy of the primary system. And the second layer, which is similar but slightly different, is virtualization high availability. Most of us are using some sort of virtualization, Hyper-V, KVM, VMware is probably the biggest one. And the virtualization subsystem provides integral high availability because it hides away, abstracts all of the hardware components, and everything is being virtualized. And they also provide a way to duplicate those. And if you look at VMware, there are two types of high availability. One of them is the standard HA. The other one is fault tolerance, where each command is executed on two virtual CPUs in parallel. So they're lockstep in between them. The third one, which is slightly outdated, I'd say, in these days, is failover cluster. Failover cluster is an active-passive configuration of two physical servers where there's a ping going on between them, some sort of a watchdog, and both of them are using shared storage. Both are installed with the same operating system, the same application stack. And once the watchdog detects that one of them has failed, it immediately transfers control over to the other one. And we're not going to talk about failover cluster, but we do support those configurations with, if I remember correctly, off the top of my head, Solaris, Windows, Linux, etc. Let's talk about database mirroring and how it works. As I mentioned earlier, the idea here is that when the application writes to the database, a single logical write from our perspective, like think in the healthcare context, think about updating a patient record, can translate into multiple updates to multiple tables in the database. And so take a single update, the minute that it goes into the primary member, before it's being written to the disk, we keep it in memory, we send it over to a secondary server, and only then, after we send it over, put it on the network, we get some sort of confirmation back from that backup server that it accepted, not yet committed the change, but accepted that change. At that point, from our perspective, this write can now be written to two separate places. So we commit it to disk, it's committed on our side, and we assume the other system will commit it to disk as well. So what happens in a failure scenario? We, as the database, detect that there's some sort of a failure. It might be that the system isn't responding because of an internal problem. It might be a disk error. It might be a power failure. It might be multiple components or any single component failing. At that point, we're doing two things. One is we handle the IP routing. So the second server is waking up. It's saying, okay, I need to own the primary's IP address. So I take ownership of that IP address. And at that point, the cache on the backup system is up and running, accepting connection from application servers, and from the user perspective, it's usually within a couple of seconds, everything fails over, so there's no interruption to the user. From that point on, users coming from the outside, any application server, just continue normal operation. There's no reconfiguration that needs to be done. At this point, usually the administrator will come in and see and get a notification of that failure, come in, check the previously primary server, the server on the left-hand side, and say, try to fix, or hopefully fix that problem, turn cache back up. And at this point, these two servers change roles. So whenever you install our cache mirroring or database mirroring, the way to look at it is two servers with without any shared infrastructure between them. So it doesn't require any shared storage or anything like that. But you have to assume that each and every one of them can handle the load as the primary. So from our perspective, they are interchangeable. Don't make one of them be 4 CPU, 32 gigabytes, or 256 gigabytes. on one hand, and the backup system is going to be only 2 CPUs and 4 gigabytes. Ain't going to work, or because at some point, and I can probably guarantee it for 90% of you, the failover will happen. And at that point, you want that second server to be able to handle the load, so you're not too stressed out about getting the primary backup and running. For talking about it, I should use the visuals probably. That would help. So how do we detect the failure on the primary? There is, whenever you set up a cluster, whenever you have 2 systems that are identical in nature, there's the challenge of what we call split brain. Each and every one of them gets isolated and decides that he's the only one in the world and he needs to continue and serve the application, and therefore he's the primary. In order to avoid that, the most common way to handle it is introduce a referee into the system. In our system, it's called an arbiter, and it's just a little piece of software that sits somewhere else within the same network, so it needs to communicate with both the primary and the backup. And at that point, you have 3 folks talking and making the decisions. The minute you have quorum, meaning you have 2 of them deciding that this guy is not responding, at that point, that's fine. But one of them will never decide that to become primary on his own. You need to have at least 2.
Question. So, how much is the delay? Is it instantaneous, basically?
It's not instantaneous, but it's definable. There's a power, usually within a few seconds. So the wet thumb in the air kind of answer is somewhere between 5 to 20 seconds will initiate a failover. You can play around with the parameters and say, okay, my system is usually slow to respond, and 8-second response time is reasonable for me. I want to extend that to be 30 seconds. Then it will happen between 30 seconds to a minute. Yes?
Is the failover also like more proactive or reactive? I mean, is it possible that a failover is going to happen, but the reason for it is actually not valid? Meaning, it's kind of like a false cause failover.
And yes, if you talk to our WRC folks, a lot of the support questions we get is, I had a failover, but both systems seems to be up and running. What happened? A common one, just as an example, is when you start a snapshot process in VMware, and you have both systems installed as virtual machines, and you start a snapshot process, it completely freezes out the machine and flushes everything to disk. Depending on your storage subsystem, that can take 10 seconds, in which case we detect that that system is not responding, fail over to the other one. And by the time our support folks look at it, both machines are up and running. Nobody knows what happened, right? Other than looking in the logs and saying that this guy didn't respond for 10 seconds. So it is, I'd say, more reactive. Okay. As an example, storage subsystems also have something called SMART, where they report level of errors. So we do not tap into that and say, well, looks like this system is going to fail in the next 3 hours, therefore we should fail over at this time. That's not what we do. We're looking at doing more intelligently failing over.
Well, like in your example, it could be that one is just performing better than the other, so you just fail over to the better performing one. And then like the slow one will catch up, right? Because of like a snapshot happening.
Yes, but that's because it's becoming non-responsive. Not because this one, again, we assume both of them perform the same in any point in time. If one of them isn't responding, it's an indication that something had failed. We don't know what it is, but we failed. So it's a thin line, but slightly different. One last thing that is sometimes overlooked, if you have this setup in your systems, and I think you should, but that's only my point of view, right? There are some side benefits. As an example, when you upgrade the system, the way that now you run a software upgrade is to upgrade one, fail over to the other one. That's now the upgraded one, and then upgrade the primary. So basically, it's a zero downtime upgrade. You never have to shut down the system. You can use the same thing for maintenance. You need to replace that server. Fair enough. We fell over to the other server. We put in a new server. We update the software, etc., and then we fail back and do it on the other side. And that's a huge benefit, at least to some of the customers where the systems are critical and there's no downtime whatsoever. In order to achieve that, as I mentioned earlier, every update to the database gets replicated. This is what we call mirroring or a primary back relationship. But the idea there is that it's being synchronous. There's also async mirroring or asynchronous mirroring, where we do not wait for a response from that backup system. So we just send all the updates somewhere else. That's very useful when it comes to two scenarios. One of them is disaster recovery. So you want to replicate those changes cross country or 300 miles from here. At some point, the propagation time comes to play, and there's no bypassing physics from that perspective. It takes time to transfer the data over there, and you do not want to wait for that acknowledgement from that other system that says, okay, I got it, and because then it will impact your performance. So it might be for some of you 20 milliseconds, for others it might be 100 milliseconds or whatever. But that's where asynchronous becomes very useful. That means that you can send those changes cross country to Florida, and when sea level rise around here and we're flooded, your data center in California is still going to be up and running. In a previous job, I had a similar capability and got a very interesting call from a guy in Florida. So you can be proactive about it. They know there's a hurricane coming. They want to move all their workload from the local data center, and they do have a disaster recovery site set up in Pennsylvania, and now we want to fail over to that. So everything goes over there. I think there was a very interesting story in Texas that I think John talked about with the latest hurricane, where we were actually able to help with transferring patient records from one hospital to the other. So when they evacuate the patients to that other hospital that isn't flooded, they can have all that data. So disaster recovery, asynchronous mirroring, and the other piece of it is for reporting purposes. So assuming you have multiple either branch offices or main systems that want to pull data from into a data warehouse and run the reports there so they don't run on your production servers, that's also possible, and you usually will use asynchronous mirroring or what we call reporting servers. Those reporting servers can receive data from multiple locations, in which case you aggregate all that data and run your reporting against that. Now, let's talk a little bit about virtualization HA. I talked about fault tolerance. I mentioned it before. That's basically when you lockstep the CPUs, and not used very much in the field still. So for VMware, the same capability is available in Hyper-V, etc. Because they're abstracting the entire hardware infrastructure, it's very easy to do high availability. Sorry? So assuming you have cache up and running on one host, the way you set up a VMware cluster to begin with is usually you have at least 2 hosts, sometimes 5 hosts, our partners in the cluster. In each and every case, there will be an additional server that's a standby host. In case something happens to one of those servers, is in charge of providing those additional resources that are required. So assuming you have a problem with something happened to that host, at this point, we are completely outside the loop. So what VMware does, it detects the failure in that host and just takes that virtual machine, transfers it over to that standby host, and restarts the machine. Now, time-wise, we're usually looking at a minute, 2 minutes. That's roughly the time frame. And then depending on the startup sequence, if you had a lot of file systems errors that needs to be corrected, a lot of journals that need to be applied, might take slightly a bit longer. And so our startup verifies the data integrity that I mentioned before, and from that point on, it's up and running. VMware in this scenario will handle all of the IP redirection, etc. Again, they control everything at the network level, storage, etc. It's very easy to do at that level. Now, there is a hybrid approach, which gives you the benefit of both worlds. In this scenario, you have 2 virtual machines running with database mirroring between them. If one of them fails, we automatically detect and fail over to the other instance, so there's 0 interruption to applications, etc. And then VMware will automatically restart that machine on a different host, so now you still have that paired machine. Now, how do you scale that up? Traditionally, when we're talking about scalability, there are different levels of scalability, and I'm sure Jeff talked about it in this scenario earlier. But there's ECP involved, or Enterprise Cache Protocol. At that point, you have application servers that can scale separately from the data server. ECP is the piece of software and usually hardware that's responsible for doing all the redirection and allowing those 2 pieces to scale separately. So assuming you have multiple application servers, ECP handles everything else from that perspective. ECP can also be mirrored, but once we introduce data sharding, ECP knows in a standard mirror configuration which of the 2 servers does it need to communicate with. In a data sharding environment, it usually communicates with the shard master. So the shard master is our go-to guy that will answer all of our queries, etc. So now you can scale horizontally the data server itself. Now, how do you mirror that? Well, pretty straightforward. Each and every one of those components needs its own mirror. So every change that goes into that data server, into that shard master, etc., gets replicated to a standby server. Any questions? No? So Evgeny, I think at this point, that's it for me.
Resources, of course, developer community.
Number one.
Number one.
I put it in number
Thank
one.
you.
It was number 2 on my initial list.
We have a lot of free online resources, of course, in InterSystems, but Oren, thank you that you put developer community on top. Appreciate. So what else we have? So we have online documentation and learning.intersystems.com. Of course, these are resources which are very useful for you and for different questions, not only how. So thank you, Oren. And of course, you guys can ask Oren directly for the questions you try to ask loudly. So, and And actually, we done with sessions, but we didn't finish with networking. So now, please continue your networking. And I think you liked our sessions we had today. And I hope in the next meetup we will see some customer solutions and success stories, not only new InterSystems features. And I think we would be ready as well. So stay tuned on developer community, and I'll look forward for our announcements.
And again, we'd like to thank the people from the CIC for hosting. And the bar will be closing in about 20 minutes. So if you want anything from the bar before you leave, please take a visit. And thank you all for coming. It was great to get you the folks.
You done streaming?